human experience, but we don't want to ill, of course, be ill and sick. So, and we have the last batch, the last portion from Mikhail Rubin today, comprehensive standards for solving inventive problems. You have floor. Please welcome. Thank you very much. I guess it's pretty curious and interesting topic. Standards for inventive problems uh, were started to be created by Mr. L. Schuler and his partners in the beginning of 20s of the last centuries, in the last century. And of course, we had the necessity to develop those standards, including the suggestions of Mr. Shulin, which were described in his books. And we want to talk about that and want to share our experience about that. So we are coming to the idea of coming from TRIZ of the 21st century, of 20th century to the 21st century. On one hand, we preserve key principles of Altshuler. On the other hand, we use our modern opportunities. So how to do it technically, technologically, on the example of those standards, we would like to show. So here are trees of the 20th century. So it was in hard copy. No computers were used. And here is the list of the principles of the tools which were used by Mr. Schuler and his colleagues. Of course, substance field analysis. I won't talk about that a lot. What does it mean? So specialists on trees, they know what does it mean. So then system of standards, there were different systems which were created by Altshuler and Violkin. So system of 76 standards, then lines of system developments, then algorithm of application of standards, and typical conflict patterns, principles of conflict resolution, and functional analysis. So here is the set of from which we collected, we combined all this instrument tool and how was the work on integration made. So we renamed substance field analysis on element field analysis. So element field analysis is used to any elements, to any systems. And I will talk about that more later. Then a universal lines of systems, like System of Standard 76 was transfigured into Universal System of Standards, and I will talk about that as well. Then algorithm of application of standards is transferred on software package Campino trees complex. And principles of conflict resolution. So the term of implementation of principles is transferred into bipolar principles. So, and also we have mono principles, which were developed by Altshuler. So on the basis of those four components of this analysis, we formulated comprehensive standards for solving inventive problems. Why they're comprehensive and what they consist of. So every standard consists of three parts. So the first is on the basis of the typical conflicts, which is the part of those interactive standards. So on the basis of those standards, we have the transfer to bipolar principles. And then the next part is the application of those universal standards to which we are used to. And then we have the standard of trimming. So then it consists of principles of trimming of different parts. So, and we'll talk more about those transfers. So we talk about mono principles and 10 additional principles which were formulated by Schuller. And in his book about creativity and science, he wrote that it was would be more effective to use not only mono principles, for example, approval and combining, so and different principles. So, so for example, uh, all those things which are in the table, like conversely or dissociation, association, is
So we have assembled them into 18 bipolar principles, and then after that we use this for technical systems and also for businesses and for design. This is one of the ways how we change this. Each bipolar approach integrates several mono approaches or mono principles. From subfield analysis to element field analysis, this is not just a completely new approach, this is a completely different viewpoint. In this subfield analysis, there were these open models possible with this field 1, followed by this substance, and followed by this field with a dot. And then these subfield schemes were used as a standard in the L-field analysis. We have it for all systems. It is applicable for all systems. Such schemes are not possible here. They should be intact closed cycle. So this element field always impacts both elements. And again, there is this element field formulae diversity. So we have this system element fields as well as there is this element field for commodities and money, and these complex element fields are also possible. So the diversity here is much wider. The next change was related to the structure of standards. There is this framework of standards, which is framework 76, which includes a list broken into parts and involving different standards. The analysis of standards here shows that we have a number of standards of a different type. We have standards where these problem situations and typical solutions are described in the form of this subfield formulae. And we also have these standards where we don't have a formulae, we only have recommendations, and we are moving to more manageable fields. This says to us that those standards are not unified and they can be complementary. So, and again, no one prevents us from having these standards with substances added. So with that, we could use other fields so they can work together with each other. So these standards and the structure of standards changed with this universal system of standards. And now we have this table which was derived of the standards. So we derived the standards with those element field structures, elimination of harmful connections, development of element field structures, and others. So those standards that are related to development lines, they were identified separately. So this combination of structure standards with standards related to development lines. So that was possible in such a way. With that, we see that we have these system-wide development lines and these synthesis of element fields. Here we have 7 interconnected options for standards. These development lines can be system-wide or they can be developed for technology, for business, or for design, or for something else. So the structure enables us to move these standards and apply them in different fields. in different domains. They are also adaptable to this software, so it is possible to use them in software suites easier than anything else. This is another change that we had throughout all these years. We now have more standards, but thanks to structuring these standards, they were simplified and now it is easier to use them. The next change, so instead of a paper-based algorithm, we use our computer-based technologies and software. And again, without computer support, without software support, this complex software shouldn't be used and couldn't be used, so it's not possible to use these standards without computer support. So we transferred from paper-based algorithms to computerized algorithms. So there is another link which helped us form those complex standards. Again, this is another development by Mr. Altschuler. It hasn't changed yet, and it's called patterns of typical conflicts. For example, one of the elements is the first one, and then one element impacts another, the second element, when there is this counteractions, and there are different variations of these interactions, both good ones and bad ones, good connections versus bad connections. There are incompatible actions when we have those typical conflicts when there are two good functions which cannot be implemented in parallel. There are other types of counteractions or conflicts. In the complex standards, we unify those typical conflicts with typical solutions. This was quite logical, logical step to make. So, and everything is really based on that. So we connected these two things together and worked jointly on that. How did we do that? And again, these complex standards include two parts, those standards, universal standards and trimming, bipolar universal standards and trimming. So for each type of the standards of the conflict, we have a set of typical approaches or principles. We also have universal standards or recommended element pool field or with that. Or we also have a number of recommendations with trimming. Those trimming recommendations are quite uniform and universal, but when we use software, they are then specified and we understand which elements we need to trim, which functions we need to trim, and this is done in an automatic mode. Pinot TRIZ handles this one with dedicated algorithms. So this is all relevant for all the types of problems. For each type of the problem, we have respective approaches, standards, and recommendations on trimming. So there is this specific example. This is the example on the vortex formation pattern of a parachute. This is a well-known classical problem, which many of you know about when in a tube we have a flow of water, and then inside this flow of water we have a model of a parachute, and here we study those vortices that are created by this model. These vortices are created by means of a paint that we have on the surface of a parachute. If our layer of paint is thick, we can continue the experiment for a long time, but if the shape is then distorted, if we use a thin layer of paint, then this model is not distorted, but we need to stop the experiment in such a case very quickly because we ran out of painting. So this is a well-known problem. How does this look like in Campino trees? We create a functional model when we have water here, which contains vortexes, then at the same time it blurs or distorts the paint, and then after that there is this blurring, which is good for painting the vortexes, but on the other hand it distorts the shape of the model, and then after that this mock-up, this dummy Again, that is all related to vortexes. So we have both bad and good links here. And using AI, we can automatically define the type of a conflict here when we define it automatically. When we do that, we see that it's possible to define these standards we can use. So this is a standard which is related to both beneficial good or bad functions, beneficial or harmful functions. Further, we recommend principles. Here we have this emptiness application, which is the solution we derive without any tables. Again, this porous materials and emptiness. So this is where we use bubbles instead of paint, or we use other gases instead of paint. And again, these bubbles always appear. And now we see that there is this emptiness which is received by the gas out of the available resources with physical or chemical effects based on electrolysis, for example. This is the specific solution which is part of the principle. So we have this control solution out of that. Again, we have recommendations on standards, and here we also have these development lines. The first thing here is using emptiness. So we use emptiness instead of an element, which is very similar and looks like a hint when we use those bubbles. When we use trimming, so we reach this level of a hint, and we use some kind of a resource element, for example, air. So I hope that you have understood the general idea for that. There is another example, which is the arc welding problem. This is a known method for studying the arc. It's not possible to see this working at the same time when there is lighting for both the spare part and the arc. If we have too much lighting, we see the arc, but we don't see the arc, we see the spare part. If we don't use the lighting, we see the arc, but we don't see the spare part. So those are the two beneficial functions that come into conflict. In the standard 67, we didn't have such a conflict type. In the typical patterns, we do have it now. So we have this problem model. In the Campino trees, we define this conflict of two beneficial functions. Then after that, we switch to typical recommendations. Further, we have this formulation of a typical conflict with the requirement to remove these conflicts. And then after that, if we look at all this, we see the examples of trimming or element fields or standards. Here, looking at the principles, so we have this continuous periodic useful action. I have already mentioned that. If you remember, this is this Suffield approach principle when we combine periodic and non-periodic actions. So periodic action means moving from uninterrupted action to a periodic one or impulsive one. Switch from continuous to a periodic pulse action. So here we have the spare part, which we see when there is no flash. When we have the flash, we see the arc, but we don't see the spare part. So again, our eye can adapt to these changes. And with that, we derive the solution, deriving this new principle based on the trimming element. We also get similar recommendations based on dynamization and structuring of the field and the structuring of the field. For trimming, we also see similar recommendations if we use the trimming approach. Here you can make a choice on how we can solve the problem by means of field introduction or measurement detection. Again, for different problems, we might have different recommendations. I believe that you have understood the general idea of the complex standards in combinatories We have integrated the standards, so you can use the standards inside the software. TRIZ 2021 is developing, taking into account new realities and resources which have emerged in the 21st century, while preserving the basic ideas and fundamental principles laid down in TRIZ by Genrich Altschuler. Comprehensive standards for solving inventive tasks are based on the connection of typical conflict schemes with three ways to resolve them. These three ways are the bipolar techniques, universal standards, and curtailing or trimming tools. Here we combine functional analysis with Suffield analysis and the scheme of conflicts, which I have mentioned at the beginning. Comprehensive standards are implemented and in the Campino Tree software suite, and they also include a solution to the conflict of two useful functions. In the software suite, this application of standards is quite simple, so intuitively you can use that easy. Without the computer suite, implementing these complex standards is not possible, I believe. At all, the structure of integrated standards allows them to extend to different areas, technology, business, design, and something else. And again, it has the potential to grow, to develop in accordance with recommendations of Ganu Culture. I have already mentioned all these factors, all these aspects, so this is pretty it. I've covered all the points. If there are any questions, I'm ready to take them. Yes, Mikhail Semyonovich, we do have questions.
Скажите, пожалуйста, составление комплексных стандартов было теоретически обосновано
So again, you showed us the link between the classical trees
законы развития
and
этических систем.
the contemporary modern trees, like what we have it. These classic approaches, we need to remember them. There is a question from Rustam. Drafting complex standards. Was it theoretically supported based on that approach, those technical systems development laws? Yes, they were supported by those ideas created by Genrich Altschuler, Suffield, as well as something else you need to remember for the 75B standard. It doesn't have the Altschuler matrix. He didn't use the table himself. So the standards described by Mr. Altschuler was something to develop principles, to develop approaches. So this development is still underway. So very often and very soon we'll see that it will be possible to just easily reject Altschuler matrix or tables, because again those examples will be then supported through the typical standards or conflicts. On the one hand, speaking of those laws that we have, again we need to be based on that. There is this trimming approach or curtailing. Many tools of trees were boiled down to different standards or approaches, which was possible thanks to using computer tools and software as well as AI. A lot of things that it was possible to derive them, to get them with the help of AI. A question from Stanislav. Mikhail Semyonovich, can you draw an example on using complex standards when it comes to global development of people, maybe for people performing robots or AI? Complex standards for in such a way, maybe. Well, I haven't tried to fight robots, my
Это провокация, Михаил Васильевич.
domain. These information systems, well, possibly you could do that. Possibly you could apply such tools for such a problem. I wouldn't fight robots. I would try to become their friend. Now, this is maybe a provocation. Well, I didn't know about it because I treat all questions seriously. Well, I understand that all these complex standards, they can be used for any tasks, for any problems, both for bad and good connections and links.
Различные инструменты, в скобках
Again, there are different principles, vice versa principles, branch principles. So you can use any of these to
сводился
try to
если
solve this
TRIZ,
problem.
TRIZ
If you do that,
большие
you
проблемы
might reach
воображения,
success. Sergey Dmitriev
распределения
has a
игровых
question.
инструментов, и тебе
Classical trees,
позволяло решателю быть уверенным
there are
в
different
правильности поиска,
tools or
предложенных
typical
объединений для
examples of
ликвидировать
standard
целые,
impacts which
следовательной
existed
организации может эту уверенность
regardless of each
снизить.
other, but there was this link anyway connecting the
Ну
two.
вот второй вопрос
But then after that, there was
Станислава.
ARIS, which also
Могут
involved
ли стандарты в полном
imagination,
объеме
links
Можно я
between different
Сергею Дмитриеву
Да, пожалуйста.
да,
different
значит,
parts of the system.
Сергей,
ARIS
большое
was used
спасибо.
to
И ваш комментарий говорит о том,
unify
что
all these elements.
вот эти
Maybe
варианты
we can
стандартов
use
это
still these
не
systems,
конечная
or are we
станция.
less
Там
confident
еще очень
of
много
using
чего
these
надо
systems? This is a
развивать,
question from
в том
Stanislav.
числе по
Can we use these standards in
инструментам
full?
логического мышления. Я согласен.
Stanislav,
Это там
Sergey,
большое
first of all, I
спасибо
thank you
за
for your
что.
question. So your comment
Да,
means that
Мгм. И второй вопрос от Станислава.
these
Могут ли
complex
стандарты в полном
standards
объеме быть
are not,
применены к,
the
могут быть
last
применены к
resort
разработке
point. We need to
научно-фантастических
develop
идей?
something else there,
Или в основном нужно следовать
also
правилам
including those
организации?
tools to develop thinking. There are
И, конечно,
very good
могут.
prospects
Значит,
out of that.
фантастическая система, она такая же система. Там можно формулировать проблемы, можно их решать. И
And
стандарты, и приемы,
can
и
we
исследования,
develop those
исследования
standards
очень
as
похоже, скажем,
per
на инструменты
sci-fi
алгоритма
ideas?
и так
You
далее.
know,
Значит,
well, if we talk
какой-то
about
четкой
sci-fi, it's
стены между
the same
ТВ
system. You
и
know,
ТРИЗ
we can
нету.
formulate problems there. We can
Эти
resolve
инструменты
them.
могут
Both
взаимно
standard
проникать друг в друга.
streaming principles, streaming very
слышно.
much like
Да,
another
извините. От Тимофея вопрос.
principle
Можно ли
tools.
применять
So
стандарты к неизобретательным
any
областям, например,
real
решению математических задач? Или если нет, то что мешает?
Смотрите,
barrier between RTV and trees? There is no
есть
barrier really,
путаница
because
идет.
those tools can go back and forth.
Комплексные стандарты.
Question from Timothy. Can we use standards in inventive
Типовые
spheres,
конфликты.
for example, for
Если
resolving
нет
math
типового конфликта,
tasks?
то
If
невозможно
not,
войти в этот стандарт.
why?
Но дело в том,
You
что
know, there
типовой
is some
конфликт
confusion.
может быть в любой области, в том числе и в математике.
If we talk
Я
about
занимался в свое
comprehensive
время,
standards
скажем,
and code
планировал
to
эксперименты, и там
them
тоже
or
были
entry to
какие-то
them
вычислительные,
are
значит, проблемы
typical
по
conflicts.
уровню
If there is no
нелинейности там,
typical
и так далее.
conflict, so then you cannot
Вот
enter
если вы в
the
математике,
standard. But the matter is that
в
in
математическом
typical
творчестве, я бы
conflict,
сказал, не в
typical
математике, потому
conflict
что
can be in
математика сама по
any
себе,
sphere, including math.
она построена на формальной логике.
For example, I
А
was
вот
dealing with
развитие
experiment
математики,
planning, and there
оно
was some
связано с
calculation
творчеством,
problems
с
on
решением каких-то
nonlinear
проблем, развитием.
approach and on and on.
И там, безусловно, можно использовать эти
For example, if
подходы.
in math or in
Там
math
могут быть только
creativity, not just in
дополнительные
math,
приемы,
but in
но система настроена таким образом, что
creativity, because
ее
math
можно
is built on
дополнять
formal
специфическими
logics, but
приемами,
development of
математическими
mathematics
приемами,
is
приемами в
related to
дизайне,
creativity and
политическими
resolving
приемами,
of some
социальными
problems
приемами.
of
Там это
development. And of
требует
course, it
работы.
goes without saying you can use those
Спасибо.
approaches.
От Александра Трегубова был вопрос, но я не
You
совсем
can
его
have some
расслышал.
additional
Он был задан
principles,
в личном
but the
сообщении, но
system is
кажется, он
adjusted
попробовал
like
сейчас.
that.
Можно
It
еще
can
раз
be
задать
added by
его
some
либо
specific
голосом, либо
mathematic
почти напрямую пообщаться?
principles in design, political
Если
principles,
этот вопрос
social
имеет несколько пунктов,
principles, and
его
of
задать
course, it
голосом
takes
Александра.
some
У нас еще есть 2 минуты.
additional development. And a question from Alexander,
Можно ли
it was
рассматривать с точки
sent in
зрения
personal chat.
как поле
Can you
системы?
ask this question again, maybe by voice directly?
Вот это интересно. Ну,
Ну,
с этой
почему
точки
нельзя?
зрения.
Кто вам мешает
I'm
ее
all yours.
рассматривать? Я с этого и начал, безусловно, там
So
есть
you may ask this question. We have 2
много
minutes to go.
инструментов, которые были. Вот видите,
So can we have a
раз,
look
два, три, четыре, пять,
at this
шесть,
as
семь
this very report
инструментов,
as
как минимум, я думаю, на самом деле больше,
polysystems?
которые были свернуты
What
да,
interferes?
можно
What hinders you to
На
look at
самом
this
деле
like
здесь
that?
по закону
Yeah, you know,
спрашивали, здесь и
there are a
переход
lot of
к
instruments, you know, 1, 2,
идеализации,
3,
да,
4,
и
5,
другие
6,
законы здесь тоже
7
присутствуют. Это
different
полисистема,
tools, and in
безусловно,
reality,
сработали.
much more,
И
which were
сработали.
trimmed. And so,
Спасибо.
as per the law,
Ну что,
so
Александр
there is a
Александрович,
transfer
спасибо большое. Я
of
думаю, что если будут еще вопросы,
from
вы сможете ответить
ideality
в
and
чате.
other principles